Hi, my name is David Candia. My partners are Rohan Nagesh and Brut Baraki, and this is our ESE5190 demo video. We have an ultrasonic radar sensor, and we're making a radar sensor that moves in 360 degrees and displays distances with the correct angles on an LCD screen. Right now I'm controlling it with a joystick, which is not the normal operation. It's just to show functionality. Essentially, our setup is we have two Atmega microcontrollers with a stepper motor and a distance sensor and an LCD. This Arduino controls the distance sensor and the LCD. So when this reads distance, it prints the correct distance to the LCD screen, but how does it get the angle? Well, this Arduino controls the stepper motor and sends the angle to this Arduino to print in the correct location. Every time the angle changes, the distance sensor sends another ping and records the distance. And if you click the toggle button on here, it starts recording data and is in autonomous mode. Oh, the gray wire is no longer, oh, this wire is disconnected. I think this wire goes here. Okay, now it's reading data. So it just reset the pin. As you can see, when it's seeing the box, it's closer. Now it's seeing me. Now it's seeing the laptop. It turns around. So this cluster right here is the box. This is me. This is the box again. So you get pretty good precision over the set of points. So I just wanted to touch specifically on the requirement satisfaction part of this project. We have input devices, ultrasonic sensor, and the joystick, and we have output devices such as the stepper motor and the LCD. We're also using ADC to get the joystick value to control the stepper motor, and we're using timers and PWM for the ultrasonic sensor. And we're also incorporating serial communication to communicate the angle between, or the angle of the stepper motor, communicating that between our two microcontrollers. Yeah, we also have some fabricated parts like these laser cut pieces to mount, and the 3D printed piece that the ultrasonic sensor is mounted to. Yeah, thank you.
Alright, so I'll be talking about the learnings that we had in this project. So basically, since we have a nice graphical radar display over here, we had to develop a new graphical library, and since we were short on pins, we had to replace the pins on another Arduino and hence in the library as well. So we had to develop basically a new graphics library for the project, and then we had to write the UART receive and the send functions by looking at our data sheet, and we had to know the working of the stepper motors. So since we had considered the servo motor earlier, we had learnings of that too, and then we basically looked at the disadvantages and advantages of both the motors, and we finally decided to go with the stepper motor. And then basically we were three different people working on different units of the project. So collaboration is something we learned, time management, since we all are busy with different projects, so that is something that we learned as well. And then based on the feedback, we adapted a few changes. So feedback based design is something that we learned new as well. And the whole product development cycle, from developing the software and making the 3D prints, everything in procedure according to the industry, is something that we learned. So that is one thing. And so the viable product of this project was to have a precision radar detector that we have done, and we are aiming at an accuracy of around 5 to 10%, which we have achieved. And that's about it. That's about it.